Today's video will demonstrate how to perform red-black balancing. Hello, I'm James Helfrich. Red-black balancing is perhaps one of the most difficult problems in all data structures, but it's actually kind of not that bad if you relate it to a 2-3-4 tree. Today's video will perform balancing on a 2-3-4 tree and do exactly the same thing with a red-black tree. Okay, so we'll start by inserting these numbers into a 2-3-4 tree in order, and we're going to use the red-black balancing just so we can see how it works. So we're going to start by inserting 80. And then 80 is black because we always have exactly one black value in a 2-3-4 node. Then we'll insert 35 and it goes to the left of 80. And then we'll insert 90 and it goes to the right of 80. Now, since it inserts as red, we always insert as red black, then this is case 2. In other words, it stays in that color. Okay, now I'm going to attempt to do 50, but notice how my 2-3-4 node is full. So I'm going to bump up this node. And now I have 1, 2, 3, 2-3-4 nodes. And that's case 3. And the case 3 is a bump. And then case 1, the node becomes black. And now I'm able to insert it. It goes less than 80, greater than 35. It goes right there. Okay. Now I'm going to insert 20. 20 is less than 80. And it's less than 35. Now I'm going to insert 40. 40 is less than 80. It looks like my 2-3-4 node is full. So I'm going to have to bump this up. So when I bump it up, this becomes red, and these two become black. And so now I'm going to redraw my nodes here. Now observe that 90 is greater than 80. 50 is between 35 and 80, and 20 is less than 35. And now I'm able to insert my 40, and 40 is between 35 and 80, so it goes right here. Maybe I should have given myself some more space. 30, less than 35, greater than 20. 70 is between 35 and 80. 95, greater than 80. 85, this is case 2 again. 10, less than 35, less than 20. And I need to insert 60. It's between here and I got to go there. Now, since this guy is full, I got to bump up, and that's case 3. And so I'm going to bump this up. But when I bump it up, it has to go in the middle here. And the middle here is a rotation. And that is case 4C. Okay, so I bumped it up. And now I can say 60 goes greater than 50, less than 80. It goes right here. Okay. So now I'm finished. Now I'm going to turn this 2-3-4 tree into a red-black tree. So every time we have the black node is always the top of the 2. Okay. Now I'm going to redraw this carefully so it's more clear how it goes. Okay. The black node is always on top. The black node's on top. The black node's on top. And that's the corresponding red-black tree. Okay, so now we're going to work through exactly the same problem, except now we're going to use a red-black BST. So first of all, I'm going to insert 80. We always insert a node as red. Then we're going to activate case number 1, which says the root must be black. Now we're going to insert 35 and 90. 35 is less than 80, so it's going to go to the left. 90 is greater than an 80, it's going to go to the right. We're going to insert as red. This can be case 2 because my parent is black, and I'm done. Now we're going to insert 50. 50 is less than 80 and greater than 35, so it goes to the right of 35. We always insert as red. Now notice my parent is red, so we have a problem. But since my parent is red and my aunt is red and my grandma is black, this is case 3, which means my parent and aunt become black. My grandma becomes red. And now I'm going to have to balance based on my grandma, which is now red. And now we're going to go case 1. My root is always black. Now we're going to insert 20. 20 is less than 80 and less than 35, so I go to the left of 35, and it always comes in as red. Notice my parent is black, therefore I'm case 2, and I'm done. Now I can insert 40. 40 is less than 80, greater than 35, less than 50, so it goes here. Now notice my parent is red and my aunt is red and my grandma's black. That's case 3. So therefore, I'm going to recolor my aunt, my parent to black. I'm going to reparent my grandma to red. And that's case 3. And now I'm going to balance based on my grandma, which is 35. 35's parents is 80, which is already black. So I'm done. That's case 2. And I continue on. Now I have to insert 30. Now 30 is less than 80, less than 35, greater than 20. So it goes right of 20. My parent is black, so this case 2, and I'm done. Now I'm going to insert 70. 70 is less than 80, greater than 35, and greater than 50, so it goes to the right of 50. My parent is black, it's case 2, and I'm done. Insert 95. So it's going to be right, so right of 90. It's going to come in as red. My parent's black, I'm done. This is case 2. 85 is going to be to the left of 90. It's going to come in as red. My parent's black, I'm done. And now case 2. Now I'm going to insert 10. It's going to be left, left, so it's going to be to the left of 20. It's going to come in as red, my parents black. Now, let's pause for a second here. Let's see if you can insert 60. I'm going to pause just a second here and see if you can do it. Okay, so 60 is going to go to the left of 70. It's going to come in as red. Notice how my parent, which is 70, is red, and my aunt, which is 40, is red, and my grandma, which is 50, is black. Therefore, this is going to be case 3, and I'm going to recolor 40, 70 to black and 50 to red. Now I'm going to balance based on 50. Now, notice 50's parent is 35 and it's red, and notice 50's aunt is 90, which is black. And so but my grandma is black too. So what's this going to be? This is actually going to be case 4C. So I'm going to put 4C on the screen here. Now, once again, I'm going to pause the video here and see if you can balance it from here. Okay, so what do we need to do here? First of all, I need to bring 90, 85, and 95 down a little bit. And I need to bring 80 down a little bit, and 80 becomes red, okay? So notice how my grandma became red in that transformation. Next thing I got to do is my 70, 60, I'm going to move up to be next to 80. Okay, so that's going to be the right node on before, the R node is going to go up to be below grandma. Now I need to have a new root node, and that root node is going to be 50. So 50 is going to go all the way up to the root, and then I'm going to turn it black. And then last, 40, which is L on my little graph there, is going to come up and be to the right of 35. Now notice this is exactly the same as the 2, 3, 4 tree that I balanced previously on the whiteboard. You can learn more about balancing in the balancing section of the binary search tree chapter of the C++ data structures textbook.